Yeah, so hello everyone, welcome to One Class and One Class. So my name is Devansh and today we are going to solve a couple of questions. So this is going to be a basic Q&A session. A little bit background about myself. So as I told you, my name. I am doing Bachelor's of Technology in Aerospace Engineering from India, and currently I am in my final year of the degree. If you need any homework help or if you need any tutoring help one-to-one session, then you can check the links in the description below, and do hit the bell icon and subscribe button so that whenever you come next time, then you would be updated for the next live stream video. And do like the video and mention in the comment section. Okay, so first we are going to start with this question. Let me just switch to, yeah. So let's start with this question. So the question says that if a data set is said to be normally distributed, what percentage of the data values do we expect to find within two standard deviations of the mean? So let us come to this tab. First, I will draw the standard deviation curve, normally distributed uh, probability curve. My drawing is not that good at this point of time. Yeah, this looks pretty better. And one more line. So these lines never touch the axis. These are basically, so this axis is basically asymptotical to this curve. So they both touch at infinity. So no mind, doesn't matter. Yeah. So at this point, we have mu, which is the mean of the standard distribution, and in this axis, which we usually say it as x-axis, we have the values of standard deviation, and we usually refer it as z. Yeah. So here we have 1, here we have 2. Let's see this curve. Okay, yeah, so here we have 1, then we have 2, and then 2 pretty close. Somewhere here, there we will have 2, then we have 3 somewhere here, and in the same way, in the negative direction, we have negative of 1, then negative of 2, uh, negative of 2, and then negative of 3. Yeah, so keep one thing in mind that this whole curve is symmetric about this axis. So in my figure it is not looking symmetric or equal, but the area in this side is equals to the area of this side of the curve. I'll just remove these lines. Yeah. So these are the values of standard deviations or sigma, and here we have the normally distributed curve. Let's see what the junior tutor, the empirical rule, also known as 68, 95, 99.7 rule, is a statistical rule that states the percentage of data that falls within 1 to 3 standard deviations of sigma, standard deviation sigma of the mean mu. For a normally distributed data set, the percentage of data that falls within the standard deviation of the mean are as follows. So, uh, we are going to verify this solution. So first, I am going to tell you that as this is a normally distributed curve, so whenever we want to find the probability, we usually find the area under the curve. So the area under the curve gives us the probability for the for a continuous distributed probability distribution. So this is a normally distributed curve. There are other curves also, like Poisson curve, and one was binomial curve also. So in this curve, so as the question states, we have to find the data set within 2 sigma. It states that 2 standard deviations of the mean. So what we need to find is basically we need to find the area from within this region. Yeah. So we need to find the area within this from -2 to +2. So I have opened the standard normal distribution table here in this tab. So in this table, I'll tell you how to read this table. So in this table, there are the values of the area corresponding to particular distribution, standard deviation. So here you can see it is saying, so here it is not saying. Yeah, so this curve is basically from the right hand side. So okay, so this curve lies from 0 uh, 0 wait, and it is mentioned in the forward direction. So basically in these kinds of table, we usually find data values running from left to right, from negative, or data values running from 0 to positive axis. So basically they do this thing because the area of this part is equal to the area of this part. So instead of mentioning the area for both the parts, as this graph is symmetrical about this mu axis or mu or mean, therefore we usually, or the data or the tables are usually given for first or one half, and we just multiplied that data with 2 to get the value of the second half. So in this data, let's see, this is the standard deviation, and we need to find for 2.00. So this part refers the first decimal place, and this horizontal table or the horizontal row represents the second and third decimal, or the second decimal. So here we need to find for 2. So for 2, you can see we need to find for 2.0. So we'll be looking for this particular value. So for z equal to 2.0, I'll use red pen. Z equal to 2.0, area under the curve from 0 to 2. So it is basically referring to this, only this part of the area, which I am highlighting with red right now, is 0.4 for 0.4772. 0.4772. So let me just do one thing. I think I have taken the wrong table. 0.4772. 2. Yeah, I've taken the correct table. Yeah. So we get the value. So one more thing, that the total area under this, the area from, wait, this area is equal to 0.5 and this area is 0.5. So it's just for basic knowledge, nothing special. Now we get the so you can see that we got the value for first half, or the we will be just multiplying this 0.4772 with 2. So it will give the area for both of the parts. If I multiply, so basically it will give area from 0 point minus 2 to 2, which will be 0.4. Let us go back to our question. 0.4772 multiplied by 2, which gives, if I use my calculator, because in this kind of, in these normal distribution or probability distribution curves, we need to be accurate till third or fourth decimal, or we need to write the values till third or fourth decimal places, because the more accurate we are, the more accurate probability we get. So if we approximate in this normally distributed curve of probabilities, then there is no sense of probability at all. Like uh, I can approximate 0.7. Like if I have a probability of 0.8, I can approximate it to 1 also. So that doesn't make sense. So this will be equal to 0.9544, which is equal to 95.44%. This data can also vary because we have taken the distribution or the values from one table. In some other table, the values can be different from at third or fourth decimal places, so this value can differ. So yeah, so this is our answer basically. I'll just mark it. So it states that 95.44% of data set values will lie within 2 standard deviations of a normally distributed curve. Here the solution, it is written 95%. It is kind of wrong. It is kind of incorrect, because as I told you that we need to be accurate till third or fourth, till at least 2 decimal places, and we cannot just approximate, because in large data set values where we deal with millions of numbers, this 0.44 percentage will make a lot of difference. So the solution, we need to be as accurate, no, I'll just write correct answer is 95.44%. This can also be, like I have seen the answer to be 95.54 or 454%. I have also seen such kind of scenes. So the correct answer is 95.44%. And what I will write uh, in probability distributions, we cannot approximate values because in data sets this to not. So pretty what the answer written here is kind of correct, but we need to, like as I told you, we need to be as accurate as possible. So correct answer is 95.44%. In probability distributions we cannot approximate values because in cases in cases where we deal with millions or large number of data sets, this two decimal places will make a lot difference. Solution is incorrect. Yeah, we have another question. Let me just put aside my calculator. Yeah, so how do we evaluate composite functions? So we have composite functions. So basically I used to do this when I was in my high school. I had these kind of questions. So let's just see what the answer written here is. In math, we have special formulas called functions that tell us an answer when we plug in a specific number. Okay. However, we can put functions together so that one function gives us a different answer depending on the answer to another. Composite function use the output of one function as an input of another. This is like a function within a function. So correct, yeah, correct definition. So let f, yeah, okay. So in a composite function, we can say, so what, yeah. Suppose we have a function which, let's say f of x. We'll take the same example as it is written here. So yeah, so suppose we take an example, let's say f of x, which is equals to 3x, and we have another example which is g of x, it is x square. So let's say if I plug in a number, let's say x equal to 1, so f of 1 equals to 3 into 1. So in the place of x we just put x equal to 1, it will give 3. In the similar fashion, g of 1 is 1 square, which is 1 only. So whenever we get a function like f of x, uh, like function in one variable, function of two variables also, f of x and y, we have like functions can be in n number of variables, but for simplicity let's just keep it at one only. So suppose if whenever we have a function like f of x or g of x, so it is a relation, or you can say it is a relation between x and f of x. So whatever values we put in, the values we put in the x, we get the corresponding relation as f of x. Sometimes we also, for simplicity, we write like this as y. So in we just say y equal to 3x. This is the equation of, like we usually see this kind of equation when we do the the what we say that plotting. And when we deal with geometry, we see such kind of equations. So we usually write this as y equal to 3x, but here we write for in when we are dealing with functions, to emphasize that function thing, we write f of x and we write g of x. We can also write one more function as h of x, which can be, let's say, 2x. Yeah. So as you have seen, when I put x equals to 1, then I get f of 1, which is 3. I get g of 1, which is 1. And let's write this also. H of 1 will be 2 into 1, that is 2. Yeah. So if I can put a number in the input of the function as x, I can also put a function as the input. So suppose if I write x equal to g of x. So if I write like this, then my f of x will be f of, I will write this value. In the case here we wrote 1, so I'll as because x was 1 here, but now x is equals to g of x, so we will write here g of x. Now what does this mean actually? What we have to do in the RHS side, because this was only for LHS. So for RHS, what we will do, here we had x equal to 1, so we put 3 into 1. So again, here we will write 3 into, now here x is g of x. Now let's say what is g of x. So g of x is x square. So I will write x as x square, because in this case my input is g of x. G of x is basically x square only. So uh, indirectly, for simplicity, usually we don't write in this way, so just don't write ever in this way. I can write this as f of x square. Yeah, f of x square also. Well, this f of x square is whole lot a different function, and f of g of x is also a different function. Here I forgot to write one bracket also. I can also write as f of x square. So here again I will write 3 into x. X is here x square, so I will write x square. This is just for explaining. Don't ever write in this way. Like, it is not prohibited to write in this way, but yeah, don't write. If we are talking about composite functions, we usually write in this way only, f of g of x, and this will be equal to 3x square. So for simplicity also, instead of writing instead of writing f of g of x, we write it as, and I also used to say this in my during my school times, so we also write this as fog of x. uh, yeah, so we also write it as fog of x, which is basically f of g of x. Let's just see. Yeah, so here you can see the answer. It is written as f of x square, so I can write this as f of x square, which is equals to 3x square. In the similar fashion, I can also write this for, let's choose a different color. Let us write with green. Now, as I have written for f of g of x, let's write it for g of f of x. So g of f of x, let's see what our g of x was x square. So when we put 1 here, we wrote as we wrote it as 1 square. Now our x is basically f of x. So f of x is 3. So first we will write f of x 3x, and then we'll square it because our g of x is basically x square. So x equals to 3x. So in this case we write the g of f of x equals to 3x, and we can always write it this as 9x square. Let's see in the solution. Yeah, the solution is written correctly. So as again I told for this as fog of x, here we write, I used to say this as golf of x. So uh, it's your choice if you want to say it as golf or fog. You can also say this as g of f of x. So this is basically um, what the senior tutor or junior tutor has written, 3x square, which is 9x square. We can also do the same thing for um, h of f of x and h of g of x. So I'm not going into each and every detail. So for let's choose black color. So I'll just write it directly. So half or h of f of x is going to be what is my h of x? It is 2 into x, and x is 3x, so it will be 2 into 3 into x. Where's my pen? Yeah, so it will be 2 into 3x will be 6x. Similarly, my h of g or hog of g equals to, g was x square, so it will be 2x square. 2 into g of x was x square, it will be 2x square. Yeah, I forgot to put the question number, so this is question number 2. This was question number 1. So the answer mentioned here is correct. So I'll just write it as correct answer. Great job. Solution is correct. Now we will move to the another question, question number 3. Question number, yeah. This states that what is extraneous solution. So here we'll write don't judge my handwriting, okay? I write better on the paper compared to this on this whiteboard. So the definition of the extraneous solution. So answer to the question, like I have also written the definition. So an extraneous solution is a root of transform equation that is not a root of original equation because it was not because it was excluded from the domain of original equation. So the here let's check the definition. The extraneous solution is the solution or root of the transform or simplified form of the given function. These solutions do not satisfy or are not valid solution to the original form of the function. For example, we ask to solve the equation or the function. Let us write this equation of function. It is x minus 1 equals to x minus 7. Yeah, so we'll just square on both the sides, so we'll get x minus 1 equals to x minus 7 whole square. I'll just expand this. So the identity for this was, I'll just write it if anyone forgot the identity. This is minus b. So a minus b whole square equals to a square plus b square minus 2ab. This is just for reference. So we will have x square plus 49 minus 14 of x. So I will rearrange all these terms. So I'll just bring x on this side. I should bring each and every term on this side. So I'll just subtract x, add 1, subtract x, add 1 on both the sides. So I will get x square. We have minus 14, so this will be minus 15x, correct, and we will have plus 1 plus 49, so this will be plus 50 equals to 0. Now when we try to find the root of this equation, we can find by using this method, factorization, or we can also use the formula. The formula I'll just write again for the reference. Formula is x equals to, so whenever you are stuck with these kind of problem where you cannot factorize the whole equation, this is the best formula which I can think of, and I always use this formula, like I don't follow this factorization technique. So this is minus b plus minus under root of b square minus 4ac upon 2a. So this will give a set of roots, basically two roots only. So as the tutor has given the, let's just see, x minus 10, x minus 5, I write this as minus 5x, x square minus 5x minus 10x plus 50 equals to 0. Now I can take x common, write x minus 5. I can take minus 10 common and I can write this as x minus 5 equals to 0. I'll take x minus 5 common, x minus 5 and multiplied by x minus 10 equals to 0. So yeah, I get two roots. So basically this condition will be satisfied, this equation is satisfied when either this term is 0, x minus 5 is 0, or x minus 10 is 0. So we'll when we put x minus 5 equals to 0, we'll get x equals to 5, and when we put x minus 10 as 0, we'll get x equals to 10. So coming back towards the original equation, we get two values of x equals to 5 and x equals to 10. Now we'll put x equal to 5 in our original equation, which was this. This was our original equation. So when I'll just put x equals to 5, so 5 under root of 5 minus 1 equals to x, it was x minus 7, right? So 5 minus 7, yeah. So 5 minus 1 is root 4 and value of root 4 is 4, 2. And here we get this will be minus of 2. So here you can see 2 and minus 2, these are not equal. So x equal to 5 does not satisfy the equation. Now let us put x equals to 10. So under root of 10 minus 1 equals to 10 minus 7. So we'll get 10 minus 1 is 9 and square root of 9 is 3 and 10 minus 7 is 3. Yeah, so this satisfied the condition or the equation. So here in this case we said x equal to 5 is the extraneous solution of the equation and x equals to 10 is the basically the normal solution or the solution of equation. Why this is happening? Because when we squared our equation, uh, when we squared this equation, we actually changed the domain. So basically in this equation there is a domain of x. So for a domain or for a set of values of x only, this equation is satisfied. But when we squared the equation actually changed into a different equation, and this is the different equation which we obtained by squaring. Now as we squared our equation, we get the domain actually changed. So basically you must be knowing this, that when we square a term, when we take the square root of a term, so suppose no, when we square a term, so basically say uh, 3. So when we square 3 we'll get 9, but when we square minus 3 also we get 9. So suppose I take under root of 9, so it will be basically plus minus 3. So here you can see the domain is the domain of the value, or the the domain of the value has minus 3 and plus 3. But when we had this function, the original function, this original function, the domain of x does not contain 5. Therefore 5 was not able to, 5 doesn't satisfy the equation. But when we put x equals to 10, it was satisfying this equation. That was because x equals to 10 was lying within the domain of this equation. So basically every equation has a domain, and in that domain there are set of values which satisfies the equation. So suppose this is the domain for this kind of equation, and when we changed our equation we get a bigger domain, and the values of x basically it can increase or it can decrease, but in this case x equals to 5 does not satisfy our equation. So we say x equals to 5 is the extraneous solution. It Here you can see the x equals to 5 is an extraneous solution because it is a solution to the transform function. Our transform function was square function, this one. So therefore it was not able to satisfy the original function. So the solution also is correct here. Mm, solution is correct. So we will move towards our next question. So this question is a numerical question. So what was the question of this number? This was 3, this will be 4. Yeah, so we need to find the curl and divergence of the vector field. Let's write the vector field. The vector field depends upon 3 variables. It is x, y squared, z square, I. I usually write like unit vectors as using a cap. So it is easy for me to distinguish between the actual variable and the unit vector. Then we have x square, y, z square, j cap plus x square, y square, z, k cap. So first let us find the divergence of this equation. So the formula for divergence, I'll just write DIV, divergence for short, or it is also written as this. This is the symbol for divergence. We write the dot operator because divergence is operated on a vector field only. So divergence of F is equal to, the formula is, so basically the formula is F of del x, f of x plus del y, f of y plus del z, f of z. So in this case our f of x is xy square z square, which and f of y is x square y z square, f of fz, basically not f of x, yeah, fz is x square y square z. Now I can write del x of f of x as, so I will just partial differentiate this f of fx with respect to x. So in partial differentiation we just differentiate x and we keep all the other variables as constant. So here differentiation of x is 1, so and y square for del f y over del y equals to, just for separating, yeah, so again I will differentiate y and I will write x square and z square. So x square z square, again differentiate fz with respect to del z. I will get x square y square, the constant, and differentiation of z is 1. So now my divergence of f, my divergence of f will be del fx of del x, which will be y square z square, plus del fy of del y, which will be x square z square, and del fz or of sorry, del fz of with respect to del z will be x square y square. So this is the answer for my divergence. So this is answer for part B first we solve part B. No problem. This was part B. We'll go to the part A. So let me see the solution for divergence. So y square z square plus x square y x square z square plus x square y square. Yeah. So solution for divergence is correct. Tick. Now we'll move to the A part. I'll go to a new page because we'll be needing. So this was question number 4 and A. So I'll just again write my vector field x comma y comma z equals to x square y square z square I cap plus x square y. I wrote this was x y square z square x z square I cap plus x square y z square j cap plus x square y square z k cap. Yeah. So I will write the formula for curl. The formula for curl, or we write it as cross product. So because when we so basically when we take the divergence of a vector field, we get a scalar field. When we take curl of a vector field, we get a vector field only. So curl of, this is the symbol for curl. We take the cross product basically. So determinant of I cap, j cap, k cap. Then we write del of del x, del of del y, del of del z, and we write fx, fy, fz. So let us find the curl of the f vector field. So I will just write determinant I j k. I will write del by del x, del over del y, del over del z. Then I will write x y square z square. So fx is x y square z square. I'll just write it a little bit bigger because we will be having a lot of terms. J cap del of del y x y z square x y z square k cap del of del z. We have x square y square and z determinant. Yep. So for finding the determinant, what we do, suppose we find the determinant for this I. So we block this row number 1. So I'll just take this. I'll just take this. So for example, when we are finding the determinant, so suppose I want to find for I, so I will block this column and this row, and then my multiplication will be this into this minus this into this. So I'll just undo to make it a bit cleaner. So I will write I into del del y of this basically fx. So I will differentiate this x square y square z with respect to y partially. So I'll get differentiation of y square will be 2y. So I will get x to x square y z. Now as you remember, we'll write minus here and we'll multiply these two terms. So when we multiply these two terms, we'll get basically we need to differentiate um, x, y, and z square. So we'll just differentiate. I think I have missed one square term here. Fy we have x square also. Yeah. So we'll just differentiate this part with respect to z. So when we differentiate, the differentiation of z square will be 2z and x square and y will be constant. So 2 into x square, y and z. Now, usually in normal when we find the determinant, normally we'll just write plus. But here, when we find the determinant or when we find the curl, we will write when we solve for j term, then we write minus. It is because when we write for j term, we'll block this column and we'll block this row. So we'll just block this column and we'll block this whole row. So we do the multiplication of this into this minus this into this. Now as we do that, basically I don't know if you remember, but the if we take I cross k, we'll get minus of j. So it is kind of like it is kind of that thing there. That's why we write a minus sign instead of a positive. So I'll just undo, 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 again, undo, 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 undo. Yeah. So I'll write minus of j vector. I'll multiply this term with this term. So I'll take the differentiation of this whole term with respect to x, partially with respect to x. So x square will become 2x and we'll have y square z minus this term multiplied by this term. So we'll take differentiation of this whole part with respect to z. So differentiation of z square will be 2z. So 2x y square and z. Then we'll write k cap. K will be plus only. No problem with k. So for k cap again, I'll just show you. We block this row and this column and we'll multiply this with this and minus multiplication of this with this. Undo, undo, undo. Yeah. I'll just choose my red pen. So del x of x square y z square. So this will be 2x y z square minus del z of del y of x y square z square. So this will be 2x y z square. Now if we just see here, we'll get, where is my cursor, where is my pointer? Yeah, my pointer is here. So if we see 2x square y z, minus 2x square y z. So this term will go to 0. This term is 0. We have 2xy square z and we have 2xy square z. So again, this term will also be 0. Wait a minute, I just need to verify my solution. For j, we wrote xy square z square, x square y z square, x square y square z, and for j we take del, so we'll get 2xy square z, 2xy square z, and subtract, we get, we are solving for j, so we'll just multiply, so we'll get 2xy square z, 2xy square z, 2xy square z, del x, 2xy square z, 2xy square z. So again, this term will go to 0. And here we have 2xy square z, and here also we have 2xy square z. And for k, we have 2xy z square and 2xy z square. So again, this whole term equals to 0. So finally, my curl of f vector is equals to 0. Let us see what is the solution given. Okay, so solution given is 2yi plus 2zj plus 2xk minus 2yk. This solution cannot be correct at all. No, the solution is incorrect. So the solution for divergence was correct, but the solution for curl is incorrect or wrong. So solution for divergence is correct, but solution for curl is incorrect. Curl of f vector will be 0. So we'll write solution is incorrect. So we'll move to the next question, question number 5. Yeah, so the question is mathematical expression. My M is not looking good. I'll just rewrite it. Mathematical expression. Yeah, so let us see what the solution is given. So definition of mathematical expression. A mathematical expression is the combination of mathematical symbols that result when numbers and variables are combined using operations such as addition, subtraction, multiplication, division, exponential, and other operations and functions. The various elements are defined below. So operations include addition, subtraction, multiplication, and division. Variables are letters used to represent like x, y, z, okay. And a coefficient is a number that is multiplied by the variable. And uh, univariate expressions have one variable, okay, yeah. While multivariable, okay, yeah, multivariate ones have more than one variable. So it is 5xy square. A term is separated from other terms with either plus, minus, and plus or minus sign, and consists of a coefficient and one or more variable. A single term may contain an expression in parentheses or other. grouping symbols in case the grouped expression is a part of that term. Example, 3x square y over x plus y. Okay, a constant consists only of a number, no variable. Answer. So yeah, so let us say we have an expression x square plus y square plus, let's write 2x square plus 3y square plus 1. So just remember one thing, that this is an expression, not an equation. An expression we do not write equal to 0. If I write equal to 0, then this will be an equation. But as it is an expression only, so this will be not equal to anything. Yeah. So in this expression, here we have 2 and 3 as coefficient. Am I writing this correct? Yeah. And I'll just choose a different color. X and y, or x square and y square, are my variables, and this one is a constant. So one and as the yeah, so a mathematical expression is a combination of mathematical symbols. So yeah, it is a combination of variables. We have the variables, we have a constant term, then we have coefficient of variables. So remember that the where the whatever number is multiplied with the variable, or whatever number is written just next to the just next to the variable, that number is called the coefficient of that variable. So basically here I can write the coefficient of x is 2. Same way x square is 2, not x. And same way I can write coefficient of y square is 3. Now the number written alone, or a number which is not multiplied with any variable, is basically just a constant term. So in this we have constant as 1, and then the operation we have used. So here I have not mentioned, but this 2 is multiplied with x square, 3 is multiplied with y square. So this I'll choose a different color. This x into multiplication, this plus sign, this what we say multiplication again this plus sign, these all are operations or operands also. So operation is just the process. So basically we are multiplying this 2 with x square. So operation is just the process. Operand is multiplication sign, or the in computer we write abstract. And here the operand is plus. We are doing the addition. And in the similar fashion, so yeah, here it is also stated that we have a univariate expression which has only one variable. We have a multivariate which has more than one. So this expression will belong to a multivariable, because we have x square and y square. We have two variables in this equation, in this expression. Sorry, don't just pardon my mistake. And we have, again I'll just give one more example. So yeah, this was the multivariate. I'll give an example for univariate. Let's say 7 plus 38 x power 4. Yeah, so this is a univariate, this is the example of a univariate expression. So again, 7 is my constant term, plus is the operand, or addition is the operation. So plus is the operand, and 38 is the coefficient, and the x power 4 is my variable. We also have one more thing also, like what is the degree of the expression. So polynomial expressions also have degrees also. So the highest order of the highest power of the, I'll just write this. So degree is basically highest power of the variable. So highest power of variable is 4 in my case. It is basically x power 4. So highest power is 4, and 4 is my degree. This is just for extra knowledge, like if someone asks the what is the degree of this expression, so you can just look at this and find the highest power of the variable, and it is going to be the degree of the expression. And again we can write any constant. Let's just go for one more example, the last example for this. Let's write 3x square y over x plus 2. So here 2 is my constant. It doesn't matter if it is in division or multiplication, but yeah, 2 is the constant term. Here if you cannot see, I can write this as 1 into. So don't think this as the coefficient of x in this case is 0. The coefficient of x, if suppose if the coefficient of x is 0, then it will be 0 into x, which will be 0. No, this is not true. The coefficient, if the x is written all alone by itself, then the coefficient of x is 1, because it is 1 into x. So never do this mistake, okay? And here we have 3x square. So again we have the degree of the polynomial, which is 2. This is a multivariate, and the coefficient 3 is my coefficient. 3 is again my coefficient, and we have x and y as variables. So the solution return a mathematical combination of mathematical symbols that result when numbers and variables are combined using operations such as addition, subtraction, multiplication. Yeah, one more, I forgot one more thing. Here the division sign is also an operation or operand. Yeah, so it consists of exponential. Yeah, so this is solution is good, correct. Solution, great job. Solution is correct. Let me go to the sixth question. Yeah, so what is a square, a rhombus? So to find that, let's first see what is a square. I'll just write the question is square a rhombus. So basically, I'll just first write the properties of a rhombus. So let's see what the properties are given here. So a rhombus is something. I'll choose the eraser. Yeah, so a rhombus is kind of this figure in which we have let's say B, C, D. So in a rhombus, all the sides are equal. So all the sides are equal, which means AB equals to BC equal to CD equal to AD. And this is the one property of rhombus. Now the another property of rhombus is that opposite sides are parallel and opposite sides are parallel. Just go with this. So in this case, AB is parallel to DC and AD is parallel to BC. Now, what it is saying that opposite angles are equal. So basically, these angles are equal. I'll just write how. So angle ADC equals to angle ADC equals to angle ABC and angle DAB equals to angle DAB DCB. Now the diagonals meet in the middle at a right angle. The diagonals of rhombus bisect each other at right angles. So let me draw the diagonals. Yeah. So these two bisect each other. So and they are at right angle. So I'll not write for the right angle. It is just a common sense. And I'll just write. So let the center point as O. So DO equals to OB and AO equals to OC. So this states the diagonals bisect each other at 90 degrees. So at 90 degrees is not mentioned here, but yeah, the diagonals bisect each other at 90 degrees. So these are the properties for a rhombus. So let us write for a square. Now I might not be able to make a perfect square, but I will try. I'll write it as PQRS. I need to draw the diagonals. Yeah, so I will write 90 because a square has 90. So in a square, all the sides are equal. So all the sides are equal, which means PQ equal to QS equal to SR equal to PR. PR. Now, for a square, the opposite sides are parallel to each other, and yeah, so the opposite sides are parallel. So let me write PQ is parallel to RS and PR is parallel to QS. Now, for a square, we don't have the property that opposite angles are equal, because eventually they are going to be equal. So for a square, all the angles or the interior angles are equal to 90 degrees. So angle PR S equals to angle PRS RSQ equal to angle RSQ is done SQP equal to angle QPR. PR is equals to 90 degree. And again, the diagonals in square also, the diagonals bisect each other. I'll just write this point as O. So again, in the square, the diagonals bisect each other at 90 degree. So this makes a 90 degree angle. And just with basic maths, we can tell that this angle is 45 degree. This angle is 45, this angle is 45, and this is 90. So this is a right angle triangle. So diagonals bisect each other. So I will write PO equal to OS and RO equal to OQ. Yeah. So these are pretty much all the properties for the square. So let us compare the properties of square and rhombus. So for a square, opposite all the sides are equal, and for rhombus also all the sides are equal. So first condition is matching. So I'll just take it here. I'll take with green color. So first condition is done. Then second condition, these sides are parallel, opposite sides are parallel. So AB should be parallel to DC and AD should be parallel to BC. So in square also opposite sides are parallel. PQ is parallel to RS and PR is parallel to QS. So second condition is also done. The third condition is opposite angles are equal. So here in this case, this angle is equals to this angle, and this one angle at D equals to angle at B. In square, the angle at P is 90 degree and angle at S is also 90 degree. So these both are equal. So opposite angles are equal here. For R and S also, angle at R is 90 and angle at Q is 90. So again, the opposite angles are equal. So opposite angle condition is also satisfied. Again, in a square also, diagonals bisect each other at 90 degree. So this condition is also satisfied. We can see that here we have AO equal to OC, we have PO equal to OS. PO equal to OS, and again here we can see we have DO equal to OB, and we have RO equal to OQ. So again the condition is satisfied. So we can say that a square is a rhombus. So every square is going to be a rhombus, but the opposite is not true. So every rhombus is not a square, because the condition for a rhombus to be a square is that all the interior angles should be 90 degree, and in every rhombus this condition is not satisfied. So the a square is a rhombus, but the opposite is not true. So the solution given, but not all properties can be found in a rhombus. That is why it is true that a square is a rhombus, but a rhombus is not a square. Correct answer. Correct solution. Great job. Solution is correct. We'll go to another question. This will be question number 7. So we need to draw the curve. How do we graph ln of x? ln of x. I just have the habit of writing magnitude. I'll just remove this because log of negative number is not possible. Yeah, so we need to graph ln of x. So let's write this ln of, as for a Cartesian coordinate system, we have an x-axis and we have a y-axis. So this ln of x is basically a function of x, and it can be also written as y. So I can write this as y equal to ln of x. Now ln of x is basically log natural of x, or log with base e of x. So this is basically log base e of x. So if the property of log, I'll just go with the property. So the property of log is, if a power b equals to c, then log of a base a c equals to b. So basically when we take log on both the sides with base a, this b comes down, and log of c with base a. So here also I can take the anti-log of this equation. So when I take anti-log, so it will go it like y e power y will be equal to x. So this is the same equation, I just transform it in a different form, so it will be easier for us to understand. Now let us find some coordinates. So let us find the k. So what he has taken y as 0, y as 1. So let's take y as -1. So for y equal to -1, x equal to, I'll just use my calculator to find the values. So for y equal, I need to find e power -1. This will be 0.3678. For y equals to 0, we get, for y equal to 0, we'll get e power 0, so x equal to 1. So anything to power 0 is basically 1. And for y equals to say 1, we'll get x equals to, it will be 2.7. For the exact value, I'll just find from calculator. So yeah, 2.7182. And for y equals to 2, the solution is given for y equal to up to 2. Yeah, so we'll just go till up to 2. So the value of e square 7.389 is 7.389. So let us confirm the values. For y equal to -1, we have x equal to 0.3678. Okay, for y equal to 0 we have 1. For y equal to 1 we have 2.71, and for y equals to 2 we have 7.38. So, okay, no problem. So the solution is a bit approximated. Now it is a better idea to draw this kind of table. I'll go to another page and I'll just draw this table. So here we have x, here we have y, to 0.36 we have -1, 0.1, so not 0.1, 0, 1, and then we have 2.71, we have 1. Then for 7.4 we have 2. Now we'll draw. As you can see, we don't, I'll just write a 0 here, otherwise it is looking a minus. So yeah, so as we can say also, like there is no negative value for ln of x because log of a negative value doesn't exist. It is a mathematical error. It gives a mathematical error also. So we'll draw one x-axis. I'll use this draw a oh god, oh god, oh god, I did a mistake. I'll just, so this will be my x, this will be my y-axis, and let's see till how much it is going. So let's say this will be my x-axis. I use a different color. I should have used a different color, but now I'll do it. So this is my y-axis, this is my x-axis. It will go up to infinity. This will also go up to infinity. This is 0, and here we had 0.36 with -1. So for y, we, let's say this is 1 minus, let's say this is 1 and this is 2. We have y from -1, 0, this is 0, we have 1 and we have 2. Then for x will go from 0.36, then we have 1, we have 2.7. So 1, 2, 3, 4, 5, 6, 7, 8. This will be for 2.7, this will be 2, this will be 3, then this was 8 and this is 7. So I'll use a different, I'll just use a black color. So for x equals to, so for x equals, so for y equal to minus, where is my cursor? Yeah, so for y equal to -1, we have x equal to 0.36. So 0.36 will lie somewhere here. Then for y equal to 0, we have 1. Then for y equals to 1, we have 2.71. So it will lie somewhere here. For y equals to 2, we have 7.4. So it should lie somewhere here. So now I'm going to draw the curve. Curve should go from this point. If you have a computer, you can draw a better curve using MATLAB or some other application. So this will go basically asymptotically. This will meet at infinity, and yeah, so finally we have completed the curve of, or we have graphed the ln of ln x. So the graph looks pretty much same. I'll use black, no, I'll use blue color. So this is coordinate number 1, coordinate 2, coordinate 3, coordinate 4. This is 1, this is 2, this is 3, and this is 4. So yeah, again solution is correct. I'll just write correct solution. Great job. Solution is correct. This was question number 7. So we'll go to a question number 8. how to find the tangent of an angle using unit circle. Okay, unit circle is kind of my favorite thing because we can find sine, cosine, and tangent, and we can find all the trigonometric ratios of any angle using a unit circle. So let us find how to find the tangent of an angle using unit circle. So in this example, the tangent of 30 degree is calculated. So I'll just use this circle only. The values from this circle is not visible properly. I have a unit circle open in this tab. Yeah, so in this tab these values are clearly visible. So let us just first go and see the. So the tangent is defined as y by x. It is the ratio of vertical line and the horizontal line formed by a certain angle to a point in the unit circle. For example, we take the tangent of 30 degree. The x coordinate and y coordinate for 30 degrees seen from the unit circle are given as 1 by 2 comma root 3 by 2. Basically x coordinates it is root 3 by 2 and y coordinate is 1 by 2. Here it is written wrong respectively. Then we write y by x, then we get the tangents. Okay. So I will use this unit circle. I'll try to make my own circle here. Oh, 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 oh. First I'll write how to find tangent using unit circle. So I'll just draw a circle here. Looks pretty good. Okay, I'll draw the axis also. Let's try with this one. Nope, 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 nope. Okay, just use a simple one. It is very difficult to operate with a circle. I hope this is the center. No, this is also not the center. Let's just take it as the center. I will move this bit. Yeah, now it looks better. So for 30 degree we have the coordinates as root 3 by 2 and 1 by 2. So these are root 3 by 2 comma 1 by 2. And now the basic idea or the basic idea behind this unit circle and how do we find the angle or the tangent or the trigonometric ratios is that basically we draw a radius from to this point to the point so that it is making 30 degree from the positive x-axis. So basically this angle is 30 degree. Now we draw a perpendicular on from this point on the x-axis. So let us say this point is P, this as O and this as R. Now we have created a right angle triangle and trigonometric ratios are defined for right angle triangle. So the formula or the tangent or the ratio of or tangent of any angle is given basically by tangent of say theta is basically perpendicular over base. So in this case, perpendicular is my this distance, the length PR. So perpendicular is PR. So perpendicular is basically the line which is like I can how can I say the opposite. Perpendicular is basically the line which is opposite to the angle. So angle here in this case we have theta equals to 30 degree, and then we have what is happening with this Microsoft OneNote. I will just write theta as 30 degree, and my base is, so base is the line or the length or the line which actually has the angle. So you can think it like this, that the angle, this line is base, this line is the hypotenuse, and this is my perpendicular line or the opposite line from the angle. So base is going to be my OR. Now tangent of 30 degree is, it is not actually x by y. For a unit circle we can write it as x by y, but it is basically the distance from so the distance of PR or the length of PR, and the length of P, I made a mistake again, it should be P. So the distance of PR is not, cannot be given by just by y always, because sometimes the center cannot lie at 0 comma 0. The center can be at say 4 comma 2 or 4 comma 5. In that case this line is not going to be the x, this line is not going to be my x equals to or y equals to 0. This can be y equals to say 3 or 2 or whatever. So the actual formula or the actual method of calculating the distance or this length or the perpendicular length is basically, it is written it as y2 minus y1, and same for x also we write it as x2 minus x1. But yeah, in this case, in the case of unit circle at 0 comma 0, at center at 0 comma 0, we have y1 and x1 as 0. So in this case we can write it as y2 by x. So let us go back to the question. So we have tangent of 30 degree y2 minus y1. So y is 1 by 2, y2 is 1 by 2 and y1 is 0. So I will write 1 by 2 over, we have x2 minus x1. So x2 minus x1, basically we have the coordinate of x is root 3 by 2, and we do not, x1 is 0, so we'll just write root 3 by 2. If you are confused what is y1 y2, then I can just tell that this coordinate is x1, this is x1, this is x2, and this coordinate is my y1. Again this coordinate is my y1 and this coordinate is my y2. So line along this is y2. Sorry for that. Yeah, so I can just cut this term and we'll get tangent of 30 degree as 1 by root 3. Let us see, tangent of 30 degree is 1 by root 3. Simplifying the radical, okay, yeah, we can also just simplify the radical by multiplying by root 3 and root 3. So we'll get root 3 by 3. It is just a simplified form, but we usually write it in 1 by root 3. So again here my solution is correct. Correct solution. Great job. So in this way you can find the tangent or trigonometric ratios of any angle using the unit circle method or the unit circle technique. Solution is correct. Now we will go to our ninth question. Question number 9. Okay, so determine the graph of tangent from unit circle. So again a unit circle question. This is same as the tangent. Okay, so it is taking for, so in this what we are going to do is that from the unit circle we are going to calculate tangent for 45, for 135, for 225 and for 315. So again I will move to my unit circle. So again we have a unit circle. I'm not going to draw this unit circle again as it is drawn here, and I'm not going to draw the triangle. I'm just going to use the coordinates. So for the coordinates I am going to just write the coordinates. So for 45 degree, coordinates are root 3 by 2 comma 1 by 2. For 135, for 135 degrees we have negative of root 2 by root 2 and root 2 by root 2. Right? For 45 it is root 2 by root 2. I did a mistake here. That's why I was wondering why it is looking a kind of bit weird. It is basically 1 by root 2 comma 1 by root 2. And again here we have root 2 by root 2. Root 2 by 2. Oh god, what is happening? So it is negative of root 2 by 2 comma and root 2 by 2. Then we will take for 225 degrees. We have for 225 we have both of them are in negative, root 2 by 2 comma negative of root 2 by 2. And for 315, yeah, for 315 degrees we have first one is positive and the second one is negative. Now let us calculate the tangents of each and every angle. So tangent of 45 degree is tangent of 45 degree is basically 1 by root 2 divided by 1 by root 2, which will be 1. Tangent of 135 degrees will be negative of root 2 by 2 divided by root 2 by 2, which is going to be negative of 1. Tangent of 225, so tangent was basically x by y by x, sorry, y by x. Oh god. Tangent is basically y by x in the case of a unit circle. So tangent of 225 will be minus of root 2 by 2 divided by negative of root 2 by 2, which will be 1. And again tangent for 315 will be up, y is minus of root 2 by 2, and this one is x is root 2 by 2. In this case this was plus and this term was minus. So again here we have negative of 1. So let us check these values here. So tangent of theta is y by x. We can get the value of tangent of each angle by substitution. Therefore tangent of 0 degree, yeah, so he has also find the tangent of 0 degree and 1 and 90 degree also. So let us find tangent of 0 degree. So tangent of 0 degree will be equal to, for 0 degree my y coordinate is 0 and x is 1, it will be 0. For tangent of 90 degree we have y is 1 and x is 0, which will be infinity. Okay, so let us see. Now we have to define a table. So here he is also finding the tangent values for 90 degree, 0 degree, then it is for 180, 270 and 360. So we'll just make a table for that. So in the table we'll write, so angles we will write in degree, theta, and we have tangent of theta. So for theta 0, theta 45, theta 90, 135, then we have 180, then we have 225, then we have 270, then we have 315, then we have 360. So from the previous calculations, let us first verify the values. So for tan 45 it is 1, for tan 135 it is negative of 1, for tan 225 it is 1, tangent of 315 is negative of 1, then for tangent of this will be basically undefined. So for tangent of 0 it is 0, for tangent of 90 degree it is undefined. So the values are correct in the table given of in this solution. So tangent of 0 is 0, tangent of 0 is 0, tangent of 45 is 1, then undefined, then it is negative 1, 0, 1, undefined, then it is negative 1, 0. Now we are going to draw the axis. I'll just draw the simple axis. Let us see, the graph is going, we have a negative value for the tangent will come in y-axis and theta will come for x-axis. So I'll just draw one longer line. Nope, I'll draw this line with a different color. I'll draw this line with blue color. I will again draw the x-axis for my case. Yeah. Now I will write this as 0.5, this as 1, this will be 0 minus 0.5 minus 1.5 1. It goes up to infinity, it goes up to minus infinity. Then we have the angles. So the angles written in 0. Yeah, so 0 we have 90 degree. Then we have 180. Then we have 270. Then we have 360. Let us write the angles in between also. So we had 45. So angle here will be 45. Here will be 135. Then 225. 25. Oh, I did a mistake. Yeah, I did a mistake. 45 will not come here. Oh God. 45, 135, 225, and this was 325, 315, 315, 315. Yeah. So I'll mark the coordinates with black color. Okay. So for tangent of here is my cursor. Black color. So this is my tangent. Basically, this is the line for tangent, and this is the line for my angles. So along this axis we have theta. So for theta 0 we have tangent as 0. So this will be my first coordinate. For theta 45 my tangent is 1. For theta 90 it is undefined. So at this we will basically have an asymptote. Now for 135 we have negative of 1. 180 we have 0, and then 225 we have 1. Then for 270 it is again undefined. So for 270 also we'll have an asymptote. So asymptote is basically an axis which runs along a curve. The curve never touches that axis, or it touches at infinity, and that is pretty much about asymptote. So for we have done for 315 we have negative of 1. 315 we have negative of 1. 360 we have 0. So it will go oh my god, this graph is kind of difficult. And here we have it will pass to this point. Here we have this, and it will go asymptotically, and for this line just pass it through this and it will touch, will be like this. Yeah, so the graph which I have made is not looking really good. It is kind of looking like linear, but the graph given in the solution is yeah, it is correct. So this is the way how we draw a tangent using the graph of a tangent using unit circle. Determine the graph of tangent from the unit circle. So I'll just write correct solution. CORRECT solution. Great job. Solution is correct. Now we'll go to the last question. I think this is going to be the 10th question. How do we find an angle between 0 and 2 pi that is coterminal with 9 minus, okay, yeah, first. So we need to find an angle from 0 to 2 pi, and the coterminal is negative of 19 by 24 pi. So basically a coterminal angle is I'll just tell you with a diagram. So let's say this is my axis. Let's say this is the this is my angle. Let us say this is 30 degree. So coterminal angle is basically the angles which will have the same terminal. And if we go, so this angle, so basically the angle coming from here will end here, and one angle will come from, this is going anti-clockwise, and this will go clockwise. Wait, I did a mistake. I'll just rub it. So for coterminal angle, we find it like for 30 it is 300. It is 300, I think. 360 minus 30 and 330 and 390. Okay. So eraser. So for coterminal, on this axis we have 30 degree. Then we'll draw 330. So this will be one angle in the negative, in the anti-clockwise direction, and this will be one angle in the clockwise direction. So it will be 390 degree, right? So 390 degree will be 30 plus, it will come somewhat like, will go clockwise. Wait a minute, I just need to cross check the coterminal angle diagram. Okay, so the diagram was something like this. This will come from here, and I'll just remake this diagram. So this is 45. Okay, let's draw it for 45. Then this, we go it in anti-clockwise direction. For clockwise direction, this will be for clockwise direction we have 315, and for anti-clockwise direction we start from x-axis and we end this angle here. This is 405 degree. So coterminal angles are basically those angles which share the same terminal, or which share the same which terminate on a same axis or same line. So for example, here we can see 45 degree. We made an axis at 45 degree. Now if we just go clockwise from positive x-axis, then we get a 315. So as we are going clockwise, this will be negative. So if we go clockwise, then we'll get negative of 315 degree, and if we end it at this term, at this axis only, then it will be 315. Again, if we start from the positive x-axis and we go anti-clockwise till this line, this 45-degree line, then again we will get an angle of 405 degrees. The formula, so here we can see that negative of 315, 45, and 405, they all are ending at same terminal. So this is the axis or the terminal at which all these three angles are ending. So we can say that negative of 315, 45, and 405 is coterminal. And to calculate coterminal, we just like for 45, we just add and subtract 2 pi, not 2 pi, 360. We are dealing in degrees, so I'll just write 360, and we will get 315 and 405. Now in our question we have find the coterminal angle of negative of 19 over 24. So it is 19 over 24 from 0 to pi. So for finding the coterminal angles, we just add or subtract 2 pi. Then if we take 0 to pi, so this is 0 and this is 2 pi, sorry, 0 and 2 pi. So 0 to 2 pi is going in anti-clockwise direction, so we will add 2 pi. If we would be going in the clockwise direction, or if the question stated that you have to go from 2 pi to 0, then it would be in anti-clockwise direction, it would be in clockwise direction, and we would have taken the negative 2 pi. But here, as it is staying as it is stating that we have to go from 0 to 2 pi, so we will take positive 2 pi because we are going in anti-clockwise direction. So minus of 19 over 24 plus 2 pi. This is pi. This is also pi. So I will just, this will be, take the LCM. So this will be 24 into 248, 48 minus 19 over 24 into 1 pi. So 48 minus 19 will be 48 minus 19, 29 over 24. 29 over 24 pi. So in the solution also exact same answer is given. So this solution is correct. So correct solution. Great job. Okay, so solution is correct. Now I will go to, so basically so this was all for this session. If you enjoyed today's Q&A session, hit the subscribe button and like, and you can also comment. And this was Devansh, the senior tutor at OneClass. And if you would like any help with your homework, or if you want to submit your questions, you can just check the The links in the description below, and I'll see you in the next video.